Introduction for Bernoulli equations is fundamental principle in fluid mechanics derived from the conservation of energy for the flowing fluids. It describes the relationship between pressure, velocity, and elevation in an incompressible, non-viscous fluid under steady flow conditions. The equation is widely applied in engineering fields such as hydraulic, aerodynamic, and pipe flow analysis. In the experiment, Bernoulli theorem is verified using a horizontal converging and diverging duct through which water flow. The pressure various point is measured using ducts through which water flow. The pressure at various points is measured using manometer and corresponding velocities.
Next, we have 4 objectives for this experiment. First, to determine the pressure head and velocity head at different points along the horizontal pipe. Second, to calculate the total head by summing the pressure head and velocity head at each point. Third, to verify whether the total head remains constant along the pipe as stated in Bernoulli equations. Fourth, to identify any energy losses that may occur due to frictions or other factors during the experiment.
Then, the problem statement for this experiment is a useful theoretical model for predicting fluid behavior. Real life application often involve factors such as frictional losses and viscosity, which are not accounted for in an ideal form of equations. This experiment aimed to investigate to the extent to which Bernoulli equations hold true under laboratory conditions the specific problem addressed to determine whether the sum of pressure head, velocity head, and elevation head. To measure the manometer tube with vernier caliper, and diameter of manometer tube is around 1 mm. Next, we will measure the length of manometer tube using ruler. Measurement for manometer tube, length of manometer tube is 33 mm. Then we need to adjust this Bernoulli apparatus level using this adjustable feet. Make sure this Bernoulli apparatus connected with hydraulic bands.
Today I want to explain how to conduct Bernoulli equation experiment. For the first, we have to initial setup, place the apparatus on the hydraulic bench, position the outflow tube above the volumetric tank. Second, installation and water filling. Install the test section in this area with the 14-degree taper facing the flow. And then we close all the valves here and here. Then start the pump and slowly open the valve to fill the apparatus with water. So next we have to removing the air from manometers and close both valves. Next, open the air bead screw to purge the air. Retighten the screw to when manometers are full. Next, if needed, slightly open the bleed screw again to adjust level or use a hand pump for pressure. Next, taking measurement with water steady and probe retracted, record manometer readings. Move the total pressure probe from H1 to H6 to measure the total head. Measure flow rate. Measure flow rate, time how long it takes to collect a known volume in the tank. Repeat for accuracy. And lastly, repeat the flow experiment and record the data. Thank you.
Assalamualaikum. For a sample calculation, I will show you the first tube only. The first step is we need to find a cross section area first by using a formula pi d square over 4, and then we need to find a flow rate by using formula volume over time. The third step is we need to find a velocity. Velocity formula is Q over A. So we already find a Q, which is flow rate, and an area. So we just use that into a formula and then we get V. And for the fourth step is we need to find a velocity head. Velocity head is by using a V square over 2G, and then we get the velocity head. So the last step is we need to find a total head, which is velocity head plus with manometer level. That's it. Thank you.
For this experiment, we have a few recommendations. First, use a more precise water flow regulator to help maintain a steady and consistent flow rate. Second, make sure there are no air bubbles inside the manometer tubes before taking any reading, so the pressure heads reading are more accurate. Lastly, calibrate the apparatus before starting the experiment to avoid any instrument error. That's all for our recommendation.
For discussion, by doing this Bernoulli lab experiment, we can see that as fluid velocity is increases, pressure will decreases, especially at the narrowest part of the venturi tube. This confirms that Bernoulli principle, which states that total energy in a steady, incompressible flow remains constant. Although the trend matched theoretical expectation, small differences occurred due to friction losses, air bubbles, and manual reading errors. Despite this, the experiment successfully demonstrated the inverse relationship between pressure and velocity, proving the practical use of Bernoulli equation in fluid flow systems. Thank you.
For Bernoulli experiment showed that Bernoulli equation is most accurate in explaining the relationship between pressure and velocity in flowing fluids. We found that when the velocity increased, the pressure decreased, just like the theory said. Although there were small differences, the result they were likely caused by friction and energy losses. Overall, the experiment helped to us understand how Bernoulli's principle works in real situations.